Concentration of ores. See, we know the ore contains a lot of undesirable substances, undesirable materials are there along with the major ore, and those all are to be separated out before leading to its major reduction process. So the method or process of removal of those unwanted substances from the ore is called concentration of ores. It's also called dressing up of ore or beneficiation of the ore, because we are actually, or enrichment of ore, because we are removing the unwanted substances, the gangue particles from the ore, and we are making or increasing the concentration of the ore before taking it into the final reduction process. Now, what all methods are to be used for which type of ore, it all depends upon the chemical and physical properties of the ore and the gangue which are there for a particular ore. Now, depending upon the basic the basic differences in their physical and chemical properties, the concentration of ore can be done in the following methods. The first method discussed is called hydraulic washing. See, hydraulic washing, what we do is we use a Wilfley table, which is having actually places where we can stock those metals. Now, what we do is the crushed and powdered ore is washed with the stream of water, and what happens is this is mainly done for those ores in which the impurities, the gangue particles in the ore differ in their densities. The gangue is very light, and is having very less density in comparison to the ores. So all heavy metal ores are like this, are actually concentrated by hydraulic washing. Since they are of the ores of heavy metal, they are having very high densities. So what happens is when they are washed with a stream of water, the ore particle settles down, and all the impurities are taken away with the stream of water. So we are left with only what? We are left with only the pure ore. The most of the unwanted material which are having lighter densities are washed away with the stream of water. And that is why this method is called hydraulic washing. Like all our ores of iron, silver and other heavy metal ores, they all are basically concentrated at least once by hydraulic washing. There is another method which is called the magnetic separation. Now, in the magnetic separation, this method, as the name suggests, is mainly done for those ores which actually are magnetically active. What we find, or the ore is magnetically non-active, but the gangue particles are magnetically active. So they both can be, in both the cases, it can be used. Now, what we do is we use this a roller like this, which is having a belt like a treadmill we are having. Now, this roller is magnetically active. Now, what happens is when the crushed and the powdered ore is actually put up on this belt, what happens is this due to this magnetic roller, the ore gets stuck to this, and then it gets separated out here, whereas the gangue particles goes down here and it can be separated. So this will be your ore. This here you will be getting the gangue particles, which are non-magnetic, whereas the ore being magnetically active gets separated out here at this end. It can be the reverse. If the gangue particles are magnetically active and the ore is non-magnetic, then the ore gets collected here and with the gangue particles on this side. Like all iron ores are basically magnetically active, so they are separated by this process. And we can also, the same process is done for castrite tin oxide ore, in which what we find is the gangue particles are magnetically active and the ore is non-magnetic. So here we get the ore, and in this case we get the gangue particles. The third method discussed in the concentration of ores is the froth flotation process. The froth flotation process is mainly done for sulfide ores, in which the ore and the gangue particles differs in their wettability. The ore gets wet by some other substance and the gangue particles gets wet by some other substance. Now, in this process, what we do, we use a large vessel, mainly in the form of a tank. Water is taken in this, and the crushed and the powdered ore plus water is taken in this. And what we do is we pass this air through this, and we add pine oil into this. Now, there are certain terms associated with this, like collector. What are collectors? These are the chemicals which are added to this in this process. which actually increases the non-wettability of a substance. So they mainly are the one which enhances the non-wettability of the mineral. So the pine oil, fatty acids, xanthates are the common examples. Now what we find is when we add a pine oil and we passes the air through this vessel in which is having water and the ore particles, the froth is formed. What we find is the gangue particles gets wet by the water, and due to which they becomes heavy and they settles down, and the ore particles gets wet by the pine oil, and which are called collectors, and they come along with the froth and they form a froth which is actually being separated out in the after some time. So this is how we can easily separate the sulfide ores which actually comes along with the froth due to the addition of the chemicals called collector from the gangue particles, due to their difference in their wettability. So that is how we can do this. We add certain chemicals like froth stabilizers. Froth stabilizers are anisole or cresol. What they do is they stabilizes the froth, which can stay for a longer time then. Otherwise, what will happen is if the froth vanishes very quickly, you won't be able to separate the ore particles from the gangue. So froth stabilizers are those which actually stabilizes the froth. We also use one more term in this process, which is called depressants. Now suppose you have an ore of lead sulfide and you wanted to separate it from its gangue particles, but it also contains impurities of zinc sulfide. Now since the impurity of the gangue particles again are in the form of sulfide compounds, they have a same wettability, and they will also come along with the lead sulfide and along with the in the form of a froth. So you won't be able to separate zinc sulfide from the lead sulfide at this stage, but then it can be done. How? By using the chemicals called depressants. What these depressants basically do, they suppresses these unwanted substances like zinc sulfide from getting along with the lead sulfide. And what we do in this is, like depressant which we use is our sodium cyanide. Now what is done in this is zinc sulfide, when reacted with this cyanide in presence of oxygen, what happens is the cyanide forms a very stable complex with zinc, like this one, and the sulfur comes out as such, like this. Now when the sulfur comes out, it's not available, it combines with the sodium and forms sodium sulfide. If we have this sodium cyanide, so what we find is the differences now is that the zinc sulfide is now no more there. It is present in the form of what your zinc tetracyanidozincate 2, this ion, or in the form of a complex which is soluble in water. So in this case what we find is we don't find now any danger of the zinc sulfide coming along with the lead sulfide. So the chemicals which suppresses the gangue particles which are there in the form of a sulfide from getting along with the ore are called depressants. Sodium cyanide is a very common depressant which is used particularly in the fourth flotation process of the lead sulfide ore. So this is what the depressants are.